Would you drive a car that seems green if you knew it required draining 500,000 gallons of water just to produce its battery? This is the reality we face with electric vehicles, or EVs, often hailed as the future of sustainable transportation. But let's dig deeper. Sure, EVs produce zero tailpipe emissions, which sounds fantastic. They help reduce urban air pollution and greenhouse gas emissions. But here's the catch. Most of the electricity that charges these vehicles comes from fossil fuels, especially in areas reliant on coal. In fact, some studies suggest that charging an EV on a coal-heavy grid could be worse for the climate than driving a hybrid. So, are we really making progress or just shifting the problem? Then there's the carbon footprint of EV battery production. Manufacturing these batteries is energy-intensive, often resulting in more carbon dioxide emissions than traditional car batteries. A significant portion of these batteries is produced in China, a country that heavily relies on coal for its energy. So, the green credentials of EVs start to look a bit murky. Let's talk about the raw materials needed for these batteries: lithium, cobalt, and nickel. The extraction of these materials is not just environmentally damaging, it's often unethical. Lithium mining, for instance, can drain water from arid regions, contaminating groundwater supplies. The so-called lithium triangle in South America holds over half of the world's lithium reserves, and its extraction practices can devastate local ecosystems. Cobalt mining, primarily in the Democratic Republic of Congo, raises serious ethical issues, including child labor and severe health risks for workers. The environmental and social costs of sourcing these materials are staggering. And what happens when these batteries reach the end of their life cycle? Landfilling them poses serious risks, from leaching toxic metals into the soil to creating fire hazards. Recycling rates for EV batteries are dismally low due to technological and economic challenges, not to mention the lack of standardization in battery design. Now, let's consider the geopolitical implications. China dominates the EV battery supply chain, raising concerns about supply chain vulnerabilities and the concentration of power in one country. This creates a precarious situation for global markets and energy independence. Despite these challenges, we can't ignore the potential benefits of EVs. They can help reduce our reliance on fossil fuels and improve air quality in urban areas, especially as we transition to cleaner energy sources. Investing in sustainable mining practices, responsible sourcing, and efficient recycling technologies could help mitigate the negative impacts of EV production. But here's the critical question. Are we merely shifting the environmental burden from the tailpipe to the mine and factory? Without a fundamental shift in our transportation systems, like creating denser, more walkable cities and investing in public transport, the mass adoption of EVs might just exacerbate existing inequalities. The future of sustainable transportation requires a nuanced approach. We need to consider the full life cycle impacts of EVs, from raw material extraction to battery disposal. While EVs can be part of the solution, they are not a silver bullet. Interestingly, emerging research suggests that hydrogen fuel cell vehicles might have a lower environmental impact than both EVs and traditional fossil fuel cars. Could hydrogen be the dark horse in the race for sustainable transportation? This unexpected contender challenges our assumptions and opens the door to exploring alternative pathways for a greener future.